Welcome back to the Lowdown on Physics. This is Screencast number 5 for Unit 1 VCE Physics Basic Electrical Circuits. Today we will be looking at power and energy. Power is defined as the rate at which energy is transformed from one form to another. So basically it's how quickly we are converting the energy. The units for power are watts. And to put it into some sort of mathematical form, we'd be saying that power equals W over T, where W is energy. So it's the number of joules of energy per second time. So equivalent units for watts would be joules per second. Now when it comes to an electric circuit, it's not something that we can readily measure. You know, we can't just pick up a resistor and go, oh well, here's our the amount of energy that's being used in it. What we can measure though is the voltage and the current that is through and across that resistor. So the equation in terms of voltage and current is voltage times current is the equivalent of power consumed. The reason for this is we have joules per coulomb, so joules on coulombs, multiplied by coulombs per second. So the equivalent units that we would then get out is joules per second. So just by analysing the units we can see that that's going to come out correctly. Now if we substitute in Ohm's law, we also get some equivalent forms for this equation. So P equals VI, but if we substitute in I equals V over R, we're going to get V times V on R, which gives us V squared on R. Or if we substitute in V equal to IR, we get IR times I, which is going to give us I squared R. So depending on what information you have for your circuit as to which form of the equation you would use in order to solve the problem. Okay, so if we now work backwards looking at our original power equation in terms of energy, we can come up with a very useful equation in terms of voltage and current to measure energy. So energy would be equal to power times time, whereas power is VI, so we could measure the amount of energy as V times I multiplied by how long it's left on for. Which kind of makes sense. How much power is it using every second? Well, if it's been left on for 20 minutes, then you multiply for how many seconds that is to work out how much energy in total. So let's consider a small example. A 12-volt battery and 2 amps of current. So find the bulb resistance. We know voltage, we know current. This is a straight Ohm's law substitution. So R equals V over I, 12 on 2, we've got 6 ohm resistance. Find the power dissipated. Well, we know V and we know I. We also know R now, so we could use any of those three equations. But the simplest is going to be P equals VI. So we've got 12 times 2, it's a 24 watt light bulb. And finally, how much energy is transformed if we turn it on for 30 minutes? Well, energy equals VIT, which is also the same as power times time. So rather than doing that calculation we did in part B, again we can use that answer. 24 times the 30 minutes times 60 seconds per minute. So that puts it into the correct units, gives us 43,200 joules or 43.2 kilojoules. Alright, that's the basics to energy and power, so we'll hit up some practice questions in class.